Part 4. Humans are altering the carbon cycle. Back in 1958, a young scientist by the name of Dave Keeling started the longest continuous record of atmospheric observations. Up until that time, no one had bothered to take and make high-precision measurements of how much carbon dioxide was in the atmosphere. Dave's objective was to get some idea of how activities were changing CO2 concentration, and so he set up an observatory in Mauna Loa at 11,000 feet in Hawaii, far from human activities. But then also to get an idea of how things might have varied globally, he worked with the shipping fleets that were going from New Zealand to Seattle. And along the way, he had those observers fill flasks with air from the bow of the ship, just like you saw singing in Titanic, so that they could get some estimates of CO2 concentration that was along a latitudinal gradient. Here's the result of what has now come to be known as the Keeling curve. So since 1958 through today, we have a continuous record of increasing CO2 concentration. When Dave started the measurements, the CO2 concentration was about 315 parts per million. Today, in mid-September, actually today's lecture is recorded on the equinox, the CO2 concentration was 411 ppm. So we've had an increase from 315 to 411 since 1958. But actually, by looking at the ice record, we can take this curve and go all the way back to pre-industrial values. And that's from the time the Industrial Revolution started in the mid-1700s through 1958, the CO2 concentration increased from 280 to 315 parts per million, all because of coal and oil combustion. Since the end of the Second World War in 1945, there's been tremendous globalization, and the result of that has been a dramatic increase in CO2 concentration. We can put this into a longer time perspective by going and looking at the Vostok Ice Core record. And the Vostok Ice Core record is a drilling through the ice in Antarctica, down through time, and pulling up pieces of ice, grinding that ice, releasing the gases, and measuring the CO2 concentration. And when we do that, what we find is that the CO2 concentration has gone from about 180 parts per million to about 280 parts per million. And as we go back in time, it's low, high, 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 low, high. What you're looking at here are glacial and interglacial records. You're looking at a history of the Earth in terms of the CO2 concentration. Now it turns out that we can take the ice associated with these different ages and measure its oxygen isotope ratio. When we measure the isotope ratio of water, we're learning something about the global temperatures at that time. And what we learn is cold, warm, cold, warm, cold, warm, so that as we go in and out of a glacial cycle, the Earth warms up when we've had an increase in CO2, and it cools off when CO2 goes down, back to the Goldilocks idea that I presented in a previous lecture. Today, though, we're far beyond that 280. We're at 400, and we're on our way, by the time you all retire, to having a value of 800 or 900 parts per million. What will that mean to global temperatures? I want to try to put this in perspective because it's very hard sometimes to think about this in a very abstract graphic way. I'm going to do it by talking about generations. I was actually young once. This is me at 1 year old in 1950, sitting on my father's lap. I graduated from high school. I looked a bit like a nerd. I got married to a wonderful, wonderful woman, and we had 2 children. That son, Josh, went to high school. He got married, and he has an 8-year-old son today named Brixton. So how much does the CO2 concentration change from one generation to the next? Well, we can plot that CO2 concentration over time, here with me, my son, and my grandson. Let's begin to look at the change. Josh's parents, when Josh's parents were born, the CO2 concentration was 315. When I graduated from high school, it was 320. And when I got married, it was 323. When Josh was born, it wasn't 315, it was 341. When he graduated from high school, it was 369. It was not 320. When he graduated from college and got married, it was 388 instead of 323. And when his son Brixton was born, their son Brixton was born in about 8 years ago, the CO2 concentration was 399. Recall that it is 411 today in September 2020. Question is, what's it going to be like when Brixton graduates from high school in a mere 10 years from now? Will it be in 2029 450? We can look at the generational differences. It changed 10 ppm in my father's generation. It changed 26 ppm in my generation. And it has changed 58 ppm in my son's generation. How much in Brixton's generation? If we extrapolate this, it might be about 100 ppm. It might be 450 to 500 ppm, as long as we continue to burn fossil fuels the way we have been. Clicker question. CO2 concentrations about 410 ppm today. What do you think the concentration will be in 2050, a mere 3 decades from now, when your children are sitting in Biology 1620? A, 425, B, 450, C, 475, D, 500, E, 550, or C, 600?